Hey Mathies, today we are going to be taking a look at the characteristics of a quadratic function. Let's get to some jokes. Okay, I think of Subway on this one. I used to have um, a slogan, wrap it up, wrap it up. All right, let me get to our screen here. And here's what the notes look like. Now, there's a lot of terminology, all right? So if you have to pause while we go through this, feel free to do that. Okay, so I'm just going to start off by reading the first couple paragraphs there with the terminology. The parent quadratic function is f of x equals x squared. I know that didn't print off the greatest. The graphs of all other quadratic functions are transformations of the graph of the parent quadratic function. Now, the transformations that we'll be taking a look at will be translation. And remember, that just means a slide. We are going to look at reflection. And that is a flip. And then dilation, which that means the size becomes bigger or smaller. The lowest point on a parabola that opens up or the highest point on a parabola that opens down is the vertex. So this is the vertex on the parent function. That happens to be 0, 0, and it is a minimum. So it means it's the lowest point on this parabola. Now, if it were to open down, we would have what's called a maximum for the vertex. Okay, so again, just some more terminology here that I'd like you to write down. And then the last thing over on the right-hand side, the vertical line that divides the parabola into two symmetric parts is the axis of symmetry. Now that's the dashed line right here. And that's always stated as x equals some number. Now, because this is on the y-axis, we are getting x equals 0. So again, just make sure that that's equal. So any axis of symmetry is going to be x equal a positive, negative. It can be an integer. It might be a decimal or a fraction. But a vertical line is always x equals. Okay, so just keep that in mind. Now, we'll actually go through that in another lesson, more with the axis of symmetry. Well, the focus today is to see what happens with the a. This is called the coefficient of the x squared. Now, a quadratic is actually y equals ax squared plus bx plus c. But again, we're just going to focus on the coefficient in front of a, and then we'll take a look at those other parts later. Anytime a is greater than 0, that gives you a positive number. So keep in mind, that's a happy parabola. It is going to open up. Now let's take a look at if we have a fraction between 0 and 1. Now what I ended up picking, I ended up typing into Desmos f of x equals 2/5 x. I also could write that squared. I also could write that as f of x equals 0.4 x squared. So what I did is I typed the parent function on line 1. So on line 1 would be f of x equals x squared. And then line 2, I typed f of x equals that 2/5 x squared. Okay, so just so you know, this was on Desmos. And eventually you'll be using that quite a bit here too. So the first thing I want you to do is let's color the parent function. We're going to make that red. I'm going to use that each time on the video. All right, and now my f of x equals 2/5 x squared. That is going to be the outside parabola. Now we call that vertical shrink. And I just had to make sure I always look back at my notes to see what the difference was. So anytime you have a fraction, it's going to be vertical shrink. And we'll kind of practice those terms as we go here. Notice that we have a minimum and it is opening upward. Same situation, okay, a is still positive. It's a positive number, so we're still happy. But this time, I'm going to use the function f of x equals 4x squared. And we're going to take a look and see what happens with that. So again, on line 1, I put the parent function. On line 2, I put 4x squared. So the first thing we're going to do, again, let's get that parent function. And then this is the 4x squared. This time it's going to be the inside parabola. Again, our vertex is at 0, 0. It's a minimum. This time we call it vertical stretch. So anytime it's a number bigger than 1, it's going to be getting closer and closer to that y-axis, and they just call that a vertical stretch. All right, let's take a look at when a is a negative value, when it is less than 0. So a little note there, I have that it is sad. Okay, so we're going to kind of just do the opposite from the other page. So I'm going to pick f of x equals negative 2/5 x squared. Okay, or I can write it as a decimal, negative 0.4 x squared. So these are the same function. One's just written with a fraction, one is with a decimal. So the first thing I want to do is the parent function. But this time, I'm also going to do the reflection of the parent function. So what I actually did on this one on Desmos, line 1 is f of x equals x squared. Line 2 was f of x equals negative x squared. And line 3 was f of x equals negative 2/5 x squared. Okay, so again, this was on Desmos, and then I just snipped a picture, put it in here. Now, the reason I want that reflection, that's really going to help us to see, okay, is it outside that parent function or is it inside the reflection of that parent function? So here's that parent function. This is the reflection of that parent function. And then you can see that just helps us. This is on the outside. And so we call that vertical shrink. So having that reflection can really help you just see, okay, yeah, is it wider than the reflection of that parent function, or is it going to be on the inside? One last situation, and this is going to be an integer that, or it can be a fraction, it can be a decimal, but it has to be smaller than negative 1. So again, I just did the opposite from the other page. I did f of x equals negative 4x squared. And again, I ended up putting that on line 3 of Desmos. So let's get your parent function. This is your parent function. This is the reflection of the parent function. And now we're going to graph that negative 4x squared. And you can see that ends up being on the inside. And because it's on the inside, we call that vertical stretch. Okay, so up in the top right-hand corner, again, I just want you to realize that this is the parent function. Really important. Parent function is f of x equals x squared. And then the reflection is f of x equals negative x squared. And just typing those in when you're trying to compare what's going on does really help you.